Yum, yum!
Greg here from Pixel Fondue. Let's make this soccer ball completely out of mesh operations. And this was based on a tutorial by William Vaughan, who did it in under a minute, of course, using direct modeling techniques. But it's good to make these things, do these little exercises with mesh operations so you can get comfortable using them, because there's some definite advantages to modeling procedurally. And as usual, the success rate of modeling procedurally depends on doing your selection operations correctly, right? Telling the mesh operations what to operate on and sort of figuring that puzzle out procedurally. So I'm going to use a kit here called Selma. It's by Steve Hill. It's just a few bucks. I'll link to it below. There's also a video on it. It has some really great selection operations in it. I don't think I used anything in this video you couldn't make in the schematic yourself, or there isn't a selection assembly already existing for. But those are a little bit more convoluted to make or use than Steve's selection operations that come in the kit. His selection operations also generally include more options and run a little bit faster. So anyway, so let's build this guy. Let's just start with an empty mesh item. We'll call it soccer ball, hit enter to rename. And over here at our stack, let's hit tab and just add a sphere to start. And pop and open mini props, the space bar. I'm going to make this a tessellated sphere and with a tessellation level of 2. So, pretty, low res soccer ball right now. But what you'll notice is some of these, the soccer ball obviously has the sort of checks or, hexes on it, right? And you'll notice like some of these, like this one will have a point in the middle with 6 different edges connected to it. And other ones will have a point in the middle with 5 different edges connected to it. So here's a point here, and here's 5 edges. So you can see we could make black hexes out of these, and then we could make white, or I guess black pentagrams out of these, and white ones out of these with the 6 different connected edges. So I need to merge some things together here. So I'm going to hit tab, add a polygon merge. And the first thing I'm going to do is merge the ones with 5 edges together. And so you see there's nothing selected, so it just merges all the polygons down to 1. So I'm going to add a selection operation. And there is one in the Selma kit down here called Select Vertices by Edge Count. Now you can create this in the schematic, and I have other videos that show you how to do stuff like this. And some of you may already know how to do this by using like a polygon or an edge operator and then selecting edges by the number of vertice counts. But you have to hook up a bunch of stuff in the schematic, and this just does it all for you over here. You just give it the minimum and maximum number of edges. So we just do 5 and 5. So we got to keep in mind that this polygon merge operation is expecting polygons to be sent to it. And right now we're just selecting vertices. So right now we're just selecting all the vertices that have, like this one here, that has 5 edges connecting to it, right? And so what we want to do is expand that one like that and then convert it to polygons. We want to do it procedurally. So I'm going to add a grow selection operation here, grow it by 1, and then I'm going to add a convert here. Now keep in mind, you're converting, oftentimes when you think of convert, I say this every time, you think of converting something into something else. But what this is asking is, what are you converting from, right? So we know polygon merge wants polygons, so we're converting from vertices, right? And here you can see that just went away. If I turn that off, you see the edges are there. If I turn it back on, they're not there. If I turn on ghosting, you can see that those are selected, right? Now the weird thing is, until convert is in the stack and this knows what it's getting, you're not going to see these pre-selected components in the view over here. I think to me, that's a bug. Like if I turn convert on and it goes through the whole stack and knows what it's getting, I can see that I selected all those there. I can see that I grew them there, and I can see that I converted them there. But if I turn convert off, I don't see that they're selected over here. To me, that seems like a bug, but you just have to take it on faith that actually is selecting them, this actually is growing them, and then that actually is converting them, and now they're merged, right? Okay, so the next thing we're going to do is we're going to do a polygon chamfer to sort of create the seams between all of these things, right? So we're going to do a chamfer, and we're going to add that right here. So we'll just do edge chamfer like that. We want to make sure selection type is set to edge. this mesh operation can operate on polygons or edges, but like you've seen, it's really important for you to know what the mesh operation is expecting. So it's expecting edges. So let's give it some procedural selection operations to feed it some edges. And what we're going to do here is grab some edges by edge length. So we know we want these guys here, these edges around all of those polygons, right? The ones we just merged. But we also want the edges in between. So we're getting something like this, right? I'm just manually selecting here, but we don't want to manually select. We want to do this procedurally. But you can see we want to put little creases between both what's eventually going to be the 6-sided polygons and also the 5-sided polygons. So we need to get some edge lengths in here because these edges are all slightly different lengths. So these sort of bridging edges from these polygons here. You can also go over here to stats and it'll show you the edge length right here, about 100, well, I'm sorry, it's 183 millimeters. And so let's do that. Let's do edge chamfer, select, and we're going to use another Selma kit here, which again, I think there's a selection assembly for this, like select edges by edge length. If not, yeah, there is one here, but we're going to actually use the one in the kit because I think it's better and I think people should buy it. So we'll just drag down here, select edges by edge length, and we want to be about 1 or 0.18 to 0.19 or so. So we got all those in between ones. Now we need to get these as well. So that edge, if I select that guy, is about 212. So let's also add, let's add one more here. So I don't want to actually create everything in between. So I do like 0.215. I'm getting every edge. So that's not helping us. We don't want the middle edges here. We have 3 different edge lengths. We have the really short ones, which are in between like that. And then we have slightly longer ones that are going from the center of these, what are going to be 6-sided polygons, the white hexes. And then we've got the ones around the edges of these pentagons here. But that's the one we want, the pentagon ones. And so, like I said, those are around 212. So we want to add another select by edge length. And in the properties, we don't want it to override the previous one. We just want to add to it. And again, this is like 210 to 215 should encompass that. Oops, not 115, 215. Now you can see we've got what we want, and we avoided these, right? So let's do our chamfer here, and I'm just going to keep it around, and we'll do an offset of like 0.01 or so, maybe a little much, maybe 0.007, something like that. Okay, it's a decent sized seam in between each of those, 0.05 maybe. And now we're going to merge all of these together, right? So let's do another polygon merge, hit tab, polygon merge. And again, it merges everything together because it doesn't have any selections yet, so it just assumes everything's selected. And here we're going to do another Selma one. Again, I think there's probably a selection assembly, and this is polygon area. And again, I'm pretty sure select polygons by area, and that's from the Selma kit. Now there is a selection assembly, but I think it's a little bit buggy, or at least has some kind of bug. But I believe there's, if you want to try it without buying his kit, I believe there's a select polygon by area one here as well. So an assembly, if you don't know, a selection assembly is not a node that's been programmed like in C. It's actually just an item that is composed of different existing nodes in MODO wired together, sort of crunched down into an item and put in this preset list here. That's an assembly versus an actual sort of node that we have over here. And so we're going to do the polygon, select by polygon area node, which is not buggy and operates better, in my opinion, than the assembly. And we just want to get an area of one of these. Now, I don't believe we have area in the info here, although you might be able to get it from a mesh info or something like that. But we can sort of guess. So let's like sort of narrow it down using our best guess of like 0.1 to 0.1. And that actually, I swear to God, I did not plan this, but it actually worked. So 0.1, if I go to like 0.3 to 0.3, that's nothing. 0.1 to 0.3 is just those guys. So that's going to grab all our triangles there. Actually, you know, we probably could have just selected the triangles, but we've got little triangles here. Anyway, but this will work. I mean, there's always like multiple ways to do this, right? You probably could have just selected by triangles and then subtracted out. the little tiny ones, but we'll just go this way, and then we're going to, yeah, we're going to merge those. So now we've got, it's starting to look like a soccer ball, all right? So let's actually go in here and create some materials really quick procedurally. So we'll just do a material tag. We'll call this one black, and that's going to be the 5-sided ones like that, right? So we're going to do black. Select by, here we'll just do select by, polygon vertices. So we can do select polygons by vertex count. Again, this is an assembly kit. There is, I believe, a selection assembly for this, or you can definitely make one using the polygon operator if you want to do that, but we'll just use the kit. So we'll select those guys, and we'll say minimum vertices, maximum vertices 5, just like that. So now those are going to be black. And then I can come over here to the shader tree. Now, unfortunately, when you create a material tag, with direct modeling, as you know, you press M, you type in the material you want, it automatically adds a tag to the shader tree. Procedurally, you have to add it on your own. So you just go over here and you add a group, and then you point it to the black one we just made, and then you just add a material in there, and then you can select the, whoops, not another group, I want a material in there. And then just hold down shift and left click and drag and turn down the value on that. I've got black, and I can just control D duplicate this up here. Whoops. Select your material tag there, control D duplicate. This one we'll call white. And let's add a new selection operation here. We'll just do the same thing, but we'll do it by 6 vertices. So select polygon by vertex, and we'll just times 6 and 6 like that. And then over here, we'll just control D duplicate the black one, and we will point it to the white one, and then in the material, shift and drag the other way. We've got white. And then let's do one more. We'll just duplicate that one more time. And here we'll just use a select by previous operation to get the seams from the chamfer node. So select by previous operation. It's a nice little backwards arrow there. And we want to pick our edge chamfer. We want to pick the new polygons. As you can see them right there. They're selected. And we'll just call this seam, like so. And then one more time, let's sometimes just double tap escape to clear out all your selections in case you have too many things selected. And then control D duplicate the white one. And let's point that to seam, and we'll just make it sort of, again, hold shift and just drag. We'll just make it kind of gray for now. Okay, so it's starting to look soccer ball-ish, right? So let's continue. Let's do a couple of subdivisions. So I'm going to just add a subdivide, and we'll do right there, this polygon subdivide. Now you can see we've got something, this isn't what we want, right? So if you look over here, the subdivision method defaults to Catmull-Clark, which is sort of a Catmull-Clark subdivision surface subdivided, sort of a nice smooth subdivide. You can also see that I've got you can see what it does to our hexes and our seam though. Now if I go to smooth, it's okay, but it also, these vertices are no longer centered. Everything's a little off kilter. But if I go to faceted, it keeps all the vertices in the center of my hexes there. I know they're not hexes, but pentagons, sexagons. And we just want to do this a couple of times, right? So duplicate it again and duplicate it again. So now we've got a lot of vertices to play with, but we need to make this spherical. Now it seems weird that there's not a sphereize mesh operation. Sphereize, cubize, those types of things are always super useful. And I know William's Nifty Kit, I think, has a sphereize mesh operation that he uses in the direct modeling. But, never fear, we can actually use a different route to get the same effect. So I'm just going to press new. I'm going to say enter and call this perfect sphere. And same thing, I'm just going to make a sphere here. And we'll do tessellation again. So we'll just, instead of globe, we'll do tessellation. This time subdivision level like 8 or something like that. See, it's really nice. And you can even do like 10, like that. And instead of 500 or like half a meter in radius, let's do just a little bit less, like 0.495. Control Alt Enter, put it on all the axes at once. Kind of pushes it in a little bit. In fact, maybe we'll do 0.48 like that. So it's mostly on the inside. But what we can do now is I'm just going to hide this. I'm going to move my camera right above everything because that's how I like to organize my scene. Let's do a mesh operation here under Deform called Surface Constraint. Now, Shrink Wrap is one that Mario Baldi wrote. I think he gave it away for free, or it It's just a couple of bucks. You can use that too if you've got it. I'm going to use surface constraint, which comes with MODO. And we're going to pick that perfect sphere to constrain to. And for mode, we'll say closest. And we want it to be double-sided so it looks both ways. And that's about all we need. I think we hit enter, and there we go. That was perfect spherical soccer ball. And again, because we're doing procedural modeling here, if we feel this like gap is too big or the seam is too big, I can always go back here to edge chamfer and just say 0.04, just narrow it down a little bit or whatever I want to do. Okay, so we're nearly done. We need to do a little bit of beveling, and so I'm just going to hit tab here. We'll do a polygon bevel. And this time we can just use the materials that we created lower down in the stack to do our selecting for us. So let's do select, tag, select by polygon tag is what we want. We want a material tag. You can use selection sets, you can use parts. We're going to use the material, we're going to pick black. And on polygon bevel, just pop an open mini props here. We want to make sure group polygons is together so they all come out as one big sort of block. And you can just use the tool handles here if you want, or press C for channel haul. And you can, we really just want to go shift, right? We don't really need to do any sort of inset. You could do a little bit of one, I guess. So let's maybe inset a tiny amount. Like, I don't know if you can see that up here. I'm gonna turn off channel haul. Let's do like, yeah, like inset like 1 millimeter maybe, and then we'll shift like 10 millimeters, something like that. Okay, looks good. And then Control D, duplicate that one, and we'll just add another selection operation. By the way, I think they're hopefully fixing some of this duplication, these duplication issues in the stack, where I'd actually rather it duplicate the selection operation as well, and just let me, pick a different material than have to re-add the selection operation. Oftentimes, when you're duplicating a mesh operation, you want a similar selection operation. Just point it to something else. In this case, we'll go white. And then our polygon bevel is already set up because we just duplicated it, and there we go, right? So it's looking pretty good. All right. Do we need much else? I think we can add a set polygon type at the top. And we'll just turn everything into a Cat McClurk sub D. Okay, looking really good here now. Again, like, I think those, I don't know what the actual seam measurements are. If you think they're too big, you can always go back to your chamfer down here and make them smaller, like so. And, that's the beauty of procedural modeling, right? Maybe just a little bit bigger. Like that. And then we can continue to do a few things here. So why don't we put a procedural UV map on it? So let me pop open the UV window on the side here, like so, and get our soccer ball here. I'm gonna just zoom out a little bit. And so let's add a UV, create UV map like this. And you can grab your ball here, and under vertex maps, you can also just hit, again, for mini props, you can get to your vertex maps through mini props and just pick texture here. Now, that's probably not what we want, but we can adjust this. So this is actually sort of interesting, doing a UV procedurally, because we can pick where we want this in the stack, right? So I can say I want like an Atlas UV. Well, that's a little bit crazy. But what if I take this Atlas UV, which again will take multiple different sort of projections, right? And sort of throw it on here and say separate by material. In fact, I don't even need to separate by material. I'm just going to take it and I'm going to drag it down underneath all these subdivides. And look at that, right? There's fewer polygons before the subdivides, so there's a lot less in terms of polygons to deal with, and we get what seems like a more reasonable sort of UV map to have to deal with. And as those UV maps are, let me just go ahead and turn all this stuff off. As these polygons are subdivided, it just subdivides the UV map, right? And so those UVs are kept in place. Surface constraint, that's not going to change the UV map. So that's one way to do it, and you can also add like a pack down there, like UV pack. Somewhere. You can do some relaxing, although I don't think it needs to be relaxed much. Pack or fit. pack. That's what we want. So double click that. Again, I'm going to put it way down here. And so they're packed and they're subdivided here. So we've got some pretty nice UVs. I can check it just by popping over to my images. In fact, let's go to my assets, and I've got some nice UV maps in my assets here. Go to images and UV. We'll just grab this one on the top here and just throw it on top of everything in a shader tree. Again, that's sort of the beauty of the shader tree in MODO. It's just going to throw everything on top. Let's go UV map texture. And there we go. Whoops. Close this. Here's our soccer ball. In fact, we can just increase the tiling a bit so you can see that it's pretty even. It's pretty decent UV map, right? Not perfect, but they never are. You can do some relaxing maybe to smooth some of those out. Let's do a little relax maybe. Add operator, UV, relax. Drag that down under pack. Oh, whoops, didn't set the UV map. Texture, sorry. Now we've got it. Yeah, okay, and that took that sort of weird curvy distortion out of it. So again, let me turn off UV relax. And you can see how some of these are sort of diamond shape. And then I turn on relax. Now they're back to squares, right? So it looks, yeah, looks pretty good. Okay, so again, UV mapping and procedural modeling, there's some advantages there, right? Because you don't have to UV map the super dense mesh. You can actually UV map it farther down in the stack before it gets dense. So there we go. I think that's good enough. I could turn that off, and then I can add maybe some more images or something. Let me just grab a Pixel Fondue image here. Let me just load a clip. All right, and I'm just gonna drag. I'm just gonna drag this onto the white one. And it's got a built-in. It's just a ping, so it's just going to. It has a built-in UV, or not UV map, a built-in alpha channel on it. And instead of UV mapping it, let's just do a planar map. And then we can go in here and go to our locator and turn off repeat. We'll just say, we'll turn it to edge like that. And then I can just select my texture locator there. And in item mode, I can just scale it down, move it a little bit, something like so. Looks good. Okay. And then, you know, we can grunge it up or something. Maybe go over to my assets and look at some of the stuff I buy off of Flipped Normals or ArtStation. I buy tons of imperfection maps, so I can grab something like this and just on the black, maybe I'll throw this on. Now, normally you would want these to be more of a roughness map or something like that than a diffuse color map, but we'll just do this for now. That's fine. We're just screwing around, trying to make it look a little rough. And then maybe one more for the white. Let's see what we got here. Make something like this. Drag it underneath. And then turn up the brightness maybe. Like that. Yeah, that's very dirty. Now, like I said, you'd probably want to use a PBR effect. You really want, you know, your grunge to be on roughness, and then you want a matching normal, and you want a matching albedo color map on that, but we're just kind of messing around here. But you can see, like, you know, it's pretty quick to get a procedural soccer ball here, and it's really helped by the Selma kit, which, again, Selma and Polly are two kits from Steve, which, again, I'll put the link below. I think you should definitely buy. Other interesting things you can do with this, let's just go back to our perfect sphere here. Let's say like a soccer ball is not going to be perfectly spherical, so let's maybe deform this guy, and then it'll, you know, our hero soccer ball will with the surface constraint will conform to this. So I'm just going to add a push operation like that. Let's turn it to polygon. Now, if I do the handle here, you can see I'm just pushing them all out along the normal. It's really just sort of inflating it. But what if I do a fall off, like a texture fall off with a fractal noise or something like that? So under tool pipe, let's add a texture fall off right here. And for our texture, let's pick like a noise texture. So I'm just going to type in noise. You'll notice all these like really nice icons here from the Shading Nerd kit, which again, you should get that. All these kits, the Warren Icons kit, the Shading Nerd kit, the Selma kits, like these are all really inexpensive, and to support MODO third-party developers, I just really suggest buying them so they keep making this type of stuff. So I'll just pick noise here. And instead of fractal, let's go to simple noise and then maybe make it a little bit smaller, like 0.33, Control Alt Enter. And now with the noise on there, when I push, you can see it's, yeah, right? So, soccer ball is not going to be that deformed. If you want to see it, let's just show you how this works. So if I deform this and hide it and show my soccer ball, since the soccer ball is, constrained to that with the surface constraint, turn that off, and we get futuristic hex ball. Looks like a roller mine from Half-Life 2. Turn it back on, we get like soccer ball left outside over winter and snow melted and you found it like I did as a kid. But you can actually, if you knock this down, just press C for channel hall here as well, or just use the tool handle either way. But if you knock this down to something reasonable like 0.01, it's slightly deformed. It's not a perfect sphere anymore. And maybe just slightly more realistic if you're creating this asset for a background item in a game or something like that. And yeah, there you go. Now there are some things that I think we can use in MODO. Of course, you could bake this down to like a lower, bake down normal maps and stuff like that to a lower res sphere and create a game asset that way. I would love to see some procedural retopo mesh operations, so I could do like a quad retopo as part of a stack, or even a volume, like convert to volume, and then do a sort of a polygon skin from a volume, stuff like that. I think MODO really needs, but you can see how fast this works, and yeah, that's it.
Yum, yum!